Hello mathematicians, welcome to our first topic for term 2, really short one on indices and logs, and the indices part at least should be pretty much revision. So for indices, we should know particularly these rules from earlier work, where if we have the same base, so that's the important part, if we multiply together variables with indices, then we add the indices. If we divide, then we subtract the indices, and if we raise an index to a higher power, we multiply the indices. You can imagine that the most common wrong thing is that if people had a to the m plus a to the n, they want to add the indices, but of course there's nothing that can be done then in that case. The best that could be done is if you had a to the m plus a to the m, that would be 2 lots of a to the m. So the normal rules of algebra apply. We can only add or subtract like terms, but when we multiply, we add the powers. Now for products and quotients, if we have AB all raised to the n, so the brackets will be important here, then it means that the A is raised to the n and the B is raised to the n. So be careful, brackets, it's all raised to the n. If it's just that, then it's only the b which is raised to the n power. For quotients, if we have a quotient, again with brackets raised to the nth, then it's the nth power of the top and the nth power of the bottom, which is also interesting. We'll come back to it later on with fractional indices and square roots. Now for zero and negative indices, then this one should be known, that a to the 0 or anything to the 0 is 1. The negative index, the little negative, simply means that we put 1 over it. So we remove the negative by putting 1 over, taking the reciprocal. So I'll just work a selection of these. They're all pretty similar. So this first one, when we're multiplying these together, we've got x to the 5 plus 5 plus 5, so this is simply x to the 15. If it was a plus sign between them, which it's not, that would be 3 lots of x to the 5. This one here, a to the negative 2 raised to the third power becomes a to the negative 6. And for what it's worth, we know that that is 1 on a to the 6th. This one here, 2 to the negative 4 raised to the negative 4th power. When we multiply those together, we've got 2 to the plus 16. Just be careful, it's a temptation sometimes to actually want to multiply, somehow or other, multiply the 4 and the 2 together. So just remember, you can't invent your own rules. You have to go with the ones which are there. Index equations are much more useful, are much more likely to turn up. So if we start with the very simple one here, and we understand what the question is asking. It's saying what power can we raise 3 to get 9 as the answer? And of course we square 3, we raise it to the power of 2. 2 to what power is 32? Well, the power of x here is the 6th, and this brings up a point that it's worth you knowing, I think. The powers of 2, ideally up to about 2 to the 10, but certainly 2 to the 5th, 6th, 7th, 8th, those sorts of powers, either you remember them or you at least can recognise when they turn up. 9 to the x equals 1 on 81. Well, the key bit here is to recognise that 1 on 81 implies that the 1 on means x will be negative. And so what power can we raise 9 to give us 81? Well, that's 2, and the fact that the 81 is on the bottom means that we're looking for negative 2. Likewise, down here, 2 to what power gives us 1 on 8? Well, if we think about 2 to what power gives us 8, then that's 3, and the fact that the 8 is on the bottom means that it's negative 3. This one here, 5 to the x equals 1/5. Well, x is negative 1. 9 to the x equals 1. Then anything to the 0 equals 1. So again, out of all of that, it's just a matter of reading what the equation is actually telling you. Fractional indices throw some people, but they're concerned with roots and powers. So if we have a to the m over n, the denominator means that we take that particular root. The m means that we raise to that particular power. So if we had a to the 1 on n, for example, that means we want the nth root. A to the m over n means that we want the nth root of either a to the m, or we want the nth root of a raised to the m, which is all the same. And you might convince yourself of that with a simple example. So if we had, for example, 8 raised to the 2/3, then that means that we can either take the cube root of 8 squared, so the cube root of 8 squared, so 8 squared is 64, the cube root of 64 is 4, or we could say that it's equal to the cube root of 8, which we know is 2, raised to the power of 2. So 2 squared, of course, is also 4. So we have an alternate way of doing it. Now this is a useful little flowchart which you might have sorted already. So if the index is negative, we take the reciprocal. If it has a denominator, we take the root, and if it does have a fractional indice, then the numerator means take that power. So again, let's just do a selection of these. So for this one here, for example, it means take the square root of 9 and cube that. So square root of 9 is 3, 3 cubed is, of course, 27. 81 to the 3 on 4th. Well, this is another case where these questions are way easier if we actually know our tables, although your calculator will cope with it. We might have a look at that in a moment. But 81 to the 3 on 4, we take the 4th root of 81, which is 3, we cube that, and 3 cubed is 27. Let's look at how we could use the calculator to do that last one. So it's 81 and x to the y, we're raising it to a power. We want that power to be a fraction, so we hit the fraction key. Up the top it was 3, down the bottom of that it was 4, and we calculate that as 27. So either learn the powers or use the calculator. So for example, in something like this, the 5th root of 32, we should know that that's a 2, and we cube it, we get an 8. Okay, write down the solutions to these index equations. So the same as before. If we had, let's just look at, say, this one here, 1/25 to the x equaling a fifth, then if we took the square root of 1 and the square root of 25, we would get 1/5. So the x in this case is a half. Likewise, 1/8 to give us 2, well 2 is the cube root of 8, so we want x to be 1/3. Down here, use surds instead of fractional indices. So if we have this one, for example, 7x all raised to the half, that's the square root of 7x. This one here, 15x to the quarter is only operating on the x, so that's 15 times the 4th root of x. X to the 4/3, that's going to be either the cube root of x to the 4th, or it's going to be the cube root of x raised to the 4th power. This one down here, using fractional indices instead of surds, square root of x to the 9th, so it's x to the 9th all raised to the half, and if we then use our power rule, that's x to the 9 on 2, x to the 4.5. This one here, 25 times the 5th root of x to the sixth means 25 times x, and it's the fifth root, so that goes on the bottom, and the sixth power up the top. 3 root x, of course, is 3x to the half. Think about which of those rules may give you problems and jot them down, then have a go at 6a.